So now let's review our behaviors of the MOS capacitor. We really have three different regimes of behavior: accumulation, depletion, and inversion. And they're separated by these two voltages, the threshold voltage and the flat band voltage. So for the P-type substrate that we've been talking about, as we saw a moment ago in terms of the depletion width, the accumulation region is going to be when we're applying a voltage such that holes are drawn to the interface. And that means that this is going to be negative voltage applied for these regions. And then a positive voltage is going to have to be applied to the gate in order to get threshold and inversion, because you have to pull electrons towards the interface. So we don't know exactly where these are on an absolute scale, as I said, because of those offsets that can be caused by fixed oxide charge and differences in work function. But we know that these behaviors are going to be more negative than these, and these behaviors are going to be more positive. And the true V equals 0 point might move around depending on work functions and fixed charges. So if I do that, then I have to move my gate voltage 0 up and down like this, so that this diagram here would move with my fingers. So now let's take a look at what charge densities are dominating the behavior in these three regimes: accumulation, depletion, and inversion. And of course, at these two crossover points, flat band and threshold, the balance is going to be switching. So we'll just look at the three definitely definable regimes. So in accumulation, for a P-type substrate, we're looking at the holes at the surface. In depletion, the major charge density is Q times the acceptor density, ionized acceptor density, times the depletion width. And then inversion, we're actually looking at a large surface density of electrons, which are pulled there by a positive gate voltage with respect to the 0. Now, of course, these things are switched in an N-type substrate, so we're going to be looking at the accumulation of electrons. And we should say out here that XD goes to 0 in accumulation. There's actually no depletion width after you go past flat band. So in an N-type substrate, we'd have ND plus and our XD, and then our holes in our inversion layer, our major charge density here. Now, along the way, for any of these cases, we might have to add in these Q fixed and have to take care of them if they're present, and that would again shift the 0 here around. But the charge densities in the semiconductor itself are these 6 values here.